And welcome to the Daily Space Weather. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you from the Smash News Network, least busted name in news, as we bring you the most detailed imagery of the sun and most comprehensive daily space weather you'll find in the known universe. Plenty of things going on here, including massive filaments on the Earth-facing portion of the solar disk and beyond. A little bit of sunspot growth down here, but overall, quite low levels of solar activity. Some major earthquakes to cover and lots more, so let's get to it. Also, another filament you may be interested in is indeed this huge helmet streamer down here. It looks like it's somewhat on the opposite side of the sun. We'll talk more about that later. Let's go around the Earth-facing portion of the solar disk here in SDO composite. 304 plus 193 angstroms is a fantastic wavelength to view both the filamentary behavior as well as active regions. So, huge number of filaments facing Earth. Likelihood of coronal mass ejections remains at nearly 100%. So you can see a huge filament down here just south of this newly growing sunspot group, which is the most likely place to see large flares at the moment. That new group right there. Here's your southeastern limb in those same wavelengths. These are all 24-hour videos, by the way. Sunspot forming just north of the Shaquille O'Neal filament. And there is your northeastern limb. Looks like a couple of sunspots may be rising there just behind the northeastern limb, right back here and over here. So anyway, let's take a look at sunspots briefly here from the SDO intensity gram from yesterday plus today. See the growth of that sunspot? Don't worry, we've got some fresh close-ups of that coming up in our sunspot analysis section. Here's your SDO colorized magnetogram. We did get two new named sunspot groups. One down here got 3268, and this one got named 3269. They're both pretty weak. The most interesting one in the Earth-facing portion of the solar disk is certainly this one. And you can see that rapid growth. Again, we'll show you some close-up images of that. Let's take a look at volcanoes briefly. Here's some fantastic time-lapse imagery of Luatolo. Yeah, Luatolo. Some lava fountaining happening there. And let's get to our list. If you're wondering what's erupting, so are we. Shivaluch starts out the list with a 15,000-foot plume of volcanic ash. Kamchatka is exploding, producing a flight level 150. Abiko, not sure if it's erupting or not. Volcanic ash not identifiable in satellite imagery. Maybe it may be cloudy over Paramushir Island. Luatolo producing an effusive explosive eruption there, and some new lava flows, at least two of them, advancing, one perhaps toward a village. So if you're in the Lesser Sunda Islands and you're actually able to see this video, frankly, we're surprised, but be aware of advancing lava flows. I'm sure you're well aware of this if you are viewing from the Lesser Sunda Islands. Semeru also exploding, flight level 160 over East Java. It's a 16,000-foot plume of volcanic ash. Popocatépetl exploding in central Mexico there, flight level 230. Fuego exploding in Guatemala, flight level 150. Nevado de Ruiz in Colombia exploding, flight level 220. Sangay exploding in Ecuador, flight level 210. That's a 21,000-foot ash plume. We're not sure about Sabancaya. Let's get to earthquakes since we've seen some major ones. But before we do that, take a moment to visit our websites. If you haven't checked out the homepage, smashomash.com, then welcome to the Neo-Renaissance. Congratulations on realizing that our channel exists. You can find links to our social media accounts. If you're interested in things like fitness and lifestyle, make sure you follow us on Instagram. If you're interested in all kinds of other additional content, make sure you follow us on Twitter, etc. If you're viewing the videos on BitChute, what are you waiting for? Go subscribe over on YouTube. You're missing like 90% of our content. Smashomash.com is the homepage. One of the links you can find there is the link to our Redbubble shop. So today's featured product is But My Galactic Current Sheet. Now this one is a direct... what's the right word? A direct criticism of a guy called Ben Davidson. He's a cosmology ignoramus who seems to think that magnetic fields govern cosmology and plasma is magic, and that there's this spooky force coming out of the galactic core called the galactic current sheet because he thinks the galaxy is very similar to the solar system. which is like a third-grade analysis of cosmology, so it's absolutely ridiculous. So if you've decided to hole up in a bunker, why not pick up a galactic current sheet throw blanket? That way you can cuddle up for the apocalypse in comfort. By the way, the blankets, like the bath mats, are extremely plush. So, yeah, be comfortable. Celebrate the apocalypse in style from behind the galactic current sheet, a fictional structure in the Milky Way galaxy invented by people like Wal Thornhill's galactic superwave theory. I seriously was frightened of the galactic core when I was in like 3rd grade for real. I'm not even kidding. The galaxy is nothing like the solar system. Next! Again, check out our merch. You can also find links to the Hemp Lucid shop below the video, so check out those products if you haven't. If you're in the market, head over to hemplucid.com, and don't forget to enter the promo code SMASHOMASH to save some dough on your checkout. Yeah, promo code SMASHOMASH to save some money on checkout, or just shop via our links. All kinds of different products there for different solutions to different issues like stress, immune response, body balms, and all kinds of CBD for your pets even available on the site. Thanks to everybody who's picked up merch. If it's time for you to re-up on your Hemp Lucid products, please do. And also, if you want to support the channel via subscription services, become a member of the Smash Team at smashomash.com/Smash Team. We launched it back in October of 2021 because we needed capabilities beyond what Patreon had. So rather than complain about it, we just built our own website. It seemed like a better idea. So consider becoming a member of the Smash Team. The bronze level requires $0 per month. The silver level is $2.99. The gold level is $9.99 a month. And you'll find extra content there. We share things that nobody else gets to see, especially for our gold level Smash Team members, like the likely mechanism underlying the solar sunspot cycles. You may be interested in that. And let's get to earthquakes, since we've had 2 approximately 7 magnitude quakes in the past 24 hours. So major seismic uptick here. The first one we should cover was on Papua New Guinea. So there is that quake. And that was a 7.0. It happened at 18:04 Universal Time yesterday evening. Now, neither of these quakes apparently produced any tsunamis. They weren't expected to. I didn't see any reports of tsunamis. If we're incorrect on that, make sure you let us know in the comments. The second large quake occurred earlier this morning on the Kamchatka Peninsula. So there's a location of that one. That was at 3:06 Universal Time this morning. That was a 6.5 is the analysis of that. Again, no tsunamis, no tsunami warning, advisory, watches, or threats issued from either of those quakes. And let's scroll up the list here, citing any other quakes above a 5 magnitude. So again, the 7.0 at Papua New Guinea happened at 18:04 Universal Time yesterday. That's April 2nd. There was also a 5.5 in the South China Sea. There's the location of that one there, kind of by the Philippines. Again, the 6.5 on Kamchatka did occur at 3:06 Universal Time this morning. It was at extreme depth, so the likelihood of tsunamis from that very low. And South Sandwich Islands also had a 5.1. And let's get back to space. Here's the past 24 hours in the ever-popular SDO 171 angstroms. And thanks for leaving a comment, Jackie2. The earthquake reports have been part of the space weather videos pretty much the entire time, and we're pushing 6 years of daily space weather content. Here's 304 angstroms, another classic wavelength. And by the way, the likelihood of even an Earth-directed coronal mass ejection really high here, because this sunspot is quite magnetically complex, and it's got this huge shack filament just to the south of it there. So that is very high likelihood of earthly events. And by the way, we are expecting a coronal mass ejection impact tomorrow. Tomorrow, yes. So NASA was off by 180 degrees on their trajectory, in our opinion. So what are you going to do? We'll just have to wait and see what happens. And let's talk about some more space weather stats. So the 10.7 centimeter radio flux, which is the most proportional data that we have to sunspot number, is now up 2 points to 127 solar flux units. So it looks like we reached a bottom there at 125 solar flux units. Another perhaps support level showing up there in solar cycle 25, right around there. And indeed, that is a very old support level. So there's a breakout coming. You can quote me on it. Yeah, quote me on it. There's a breakout coming. And that's a 1-year graph, by the way. It shows you the red line is the sunspot number, and the black line is a 10.7 centimeter radio flux. Space Weather Enthusiast dashboard here, not forecasting any geomagnetic storms or geomagnetic unrest. We are expecting sometime around this range a possible KP7 or even a KP8. And this could continue. Let's see. We'll end the alert right about here. So the second half of the day universal time tomorrow and the first half of the day universal time on Wednesday, April 5th. We're expecting to see geomagnetic storm conditions, and they could be strong, as it looked to us like that CME was directly headed toward Earth, not directly away from Earth, as many have suggested. So anyway, we'll see what happens. That's your Space Weather Enthusiast dashboard. This is NOAA's forecast, and our forecast is regularly different from NOAA's, so that's part of the reason why we make the videos. Also, another major reason we make the videos is because of hacky space weather misrepresenters on YouTube making millions of dollars per year. So here are the past 4 hours of Earth's magnetic moment from space. And things are pretty calm here. You may see some pretty rapid variations happening in that, and that's got to do with the model and the real-time solar wind data. So we're going to explain that here in a minute. Just keep in mind that some of this model may be a little bit janky there. It may be a little bit jacked up because of an instrument switch. So you'll probably see a pressure increase right here toward the end. There's that pressure increase. That's probably an anomalous pressure increase that wasn't a real pressure increase. Again, we'll explain that when we show the real-time solar wind data. Here's Earth's magnetic moment from the ground, also for the past 4 hours. And here you should see a little uptick as well. Geospace delta B, that's changes to Earth's B field, the field that goes through the magnet being the Earth. There's that little uptick at the end. And the planetary K index currently at 2. KP2 is the current situation. If you're not familiar with the planetary K index, it's an average of earthly geomagnetism. Next, we'll look at the real-time solar wind. It's measured out here at Lagrangian point 1, the location of the ACE and Discover spacecraft. Also, the SOHO is out there. And this is what we're talking about here. This sudden increase in the solar wind density, that is not a CME impact. That is switching from the ACE and Discover. That's switching from the ACE to the Discover. So you see this green line down here? That's the ACE. The blue line is a Discover. The instrument's switched. It doesn't necessarily mean one's wrong or right. Keep in mind the Lagrangian point 1 is fairly large, so the orbits of these things are kind of big, and they can be in a completely different solar wind regime in their different respective locations. So, but in any case, the current instrument is the Discover, and the current Discover data is showing 500 kilometers per second for the solar wind speed and just under 10 protons per cubic centimeter for the solar wind density. Next, we'll look at the magnetometers from the GOES 16 and GOES 18. There you go. Pretty smooth here. We are seeing a subsiding of a coronal hole wind stream, and it's taken its good old time ramping down. We'll keep you posted on that. And of course, there could be interactions there with the incoming likely coronal mass ejection. Let's take a look at the heliospheric current sheet next. So here's the heliospheric current sheet. Earth is in a south pole current sheet. There is a north pole current sheet headed this way. And it may be getting stalled a little bit there. You can see that sector boundary crossing moving around a little bit, an indication of some possible active regions there, and especially ones north of the solar equator. So, possibility of a couple of sunspots rising in the northeastern portion of the Earth-facing solar disk. We'll be keeping you posted on that as well. Let's take a look at Earth's at the line of sight field plot here. Here is the solar B field depicted in blue. South solar polar field facing the Earth there in red. North solar polar field there just coming around in the east. And let's take a look at coronal holes. By the way, we're going to show some cosmic ray report today as well as historic coronal holes. So this is exactly 11 years ago. This is the 2012, that's March 30th, 2012 through April 3rd, 2012. And that's our line of sight coronal hole plot for exactly 11 years ago. So that's what the solar B field and the coronal hole plot looked like. You can see quite a bit of North Pole magnetism there, down around the South Solar Polar region. The heliographic polar region down here, you can see a lot of North Pole magnetism still hanging out down there. And a lot of it's made its way to the North Heliographic Pole. Meanwhile, the South Solar Polar Field is largely closer to the equator and mid-latitudes. Meanwhile, so again, that's 11 years ago on these same calendar dates. And then here is the current line of sight coronal hole plot. See a very different scenario happening there. The solar B field here a lot more organized than it was 11 years ago during solar cycle 24's ramp up to solar maximum. Again, there is 11 years ago, and there is the past 5 days. So just to give you a little historic context there of a similar time, at least in terms of the location of the coronal holes and the solar B field and so on. We'll show you that one more time here. There is 11 years ago. That's March 30th through April 3rd, 2012. And there's March 30th through April 3rd, 2023. So here's a 24-hour video of coronal holes from SDO. That's 211 angstroms. Let's bring up the last frame here just for reference. So we do have some North Pole-oriented coronal holes here rotating into the east. So this one's, oh, interesting. This one's looking very well defined already. There's a North Pole coronal hole. These are also North Pole coronal holes down here. And these are South Pole coronal holes. So the sector boundary is kind of making its way across here. Again, there's the latest image. South Pole coronal holes there in the northwest. North Pole coronal holes in the southeast. Next we'll get to sunspots, since they're sort of important also. And there's what's going on with the photosphere. And again, the sunspot to watch is certainly sunspot 3270. Yeah, 3270. That is this one. That's this one here. Number 5. It's the most likely to produce large flares at the moment. Let's take a look at some more 24-hour videos here from SDO. Here is SDO Continuum plus 171 angstroms. It helps to show active regions there. That's why we have the 171. Let's get a little closer here. See the rapid growth of that sunspot 3270. Let's drop the 171 angstroms. Besides that, sunspot activity has been quite stable here. Here's a close-up. The last 24 hours of that sunspot. And we'll show you high-res imagery of that later in the video to analyze its magnetic fields. Is it beta-gamma class or is it beta-gamma delta class? Let us know in the comments what you think. We'll show high-res magnetometers of that just before our meteorology segment. Now let's do a cosmic ray rundown. We haven't done it for a while here, so we're going to look at cosmic rays from about 7 different cosmic ray monitors. 7 or 8? 3, 4, 5. I think 8 actually. Anyway, there's DOMB Antarctica, And DOMB Antarctica is showing a downtick here in the past 30 days, but a very modest downtick. DOMC Antarctica, also a very modest downtick, almost flat at DOMC Antarctica for the past 30 days of cosmic ray flux. Oulu's neutron monitor there showing a modest uptick in the past 30 days. Little uptick there at Oulu, Finland in cosmic ray flux. And by the way, we're right near the bottom of solar cycle 24's cosmic ray flux. One of the many, many, many indications that this is not a grand solar minimum and that solar cycle 25 will be vastly more active than solar cycle 24. Anyway, let's go way down south to Mexico City. So there's Mexico City's cosmic ray observatory, and you can see a modest uptick in cosmic ray flux there over the past 30 days as well, almost flat at Mexico City. Let's go to Greece next. Here is your Athens neutron monitor. And Athens looks like it's a tiny uptick there at Athens as well over the past 30 days, almost flat. And we'll also look at Apatit and Barentsburg. So going way back up north, you can see that Apatit is showing a modest uptick, almost flat, and also Barentsburg. Barentsburg, one of the outliers there, showing a little downtick in cosmic ray flux, but also almost flat. That's your cosmic ray report, and let's talk about energetic particles. Solar energetic particle events have been non-existent, so no relativistic particles are showing up in the GOES proton flux. The likelihood of seeing a spike in this goes up with that sunspot right in the Earth-facing portion of the solar disk. GOES X-ray flux here has been propped up by that same sunspot, 3270, I believe it's called. And the largest flare of the past 24 hours was about a C2.5. That one's very similar. And let's take a look at 94 angstroms for the past 24 hours. Flaring being supported by largely just one sunspot group. This area down here is not a sunspot, at least it wasn't when we did show prep. It was just a plage. And congratulations on retirement, Tin Man 1057. Next, we'll take a step back and look at what's going on overhead. You just press the Now button, and you have the current situation. This is skyandtelescope.org's star chart, if you're wondering. Put in your zip code to create your own. And if you've got clear skies after sunset, you may see Jupiter and Mercury there, chasing the sun across the ecliptic as the sun chases Saturn across the ecliptic. If you're up before dawn, you might see Saturn there, one of the brighter objects visible in the sky. So here's your solar system forecast. We'll advance this 1 week to show you what's going to be going on as Mercury and Venus are making their way around to this lonely side of the solar system. Here's where things are today on April 3rd. And there's where they'll be in 1 week on April 10th. And let's take a look at coronagraphs. Again, just to reiterate, NASA had that recent CME headed this way, and we've got the recent CME headed this way. So just so you are aware of that. It's a margin of error of 100%. And yeah, it's a 180-degree difference in the trajectory. So here is yesterday's coronagraph data from here are yesterday's coronagraph data from George Mason University. And yes, I do know how to conjugate verbs. Let's see if we have anything from today yet. I'm just going to press refresh. Nope. So there are yesterday's coronagraphs. And let's take a look at some additional information here from Stereo A. Located right there, just only a few degrees behind the Earth here, and also the Soho-Lascaux C3. So you can see this huge filament down here. I mean, this filament is just, it's so big it's reaching almost to the edge of the Soho-Lascaux C3. You can see that bright spot right there, also reflected on Stereo A. That is a gigantic filament. I suspect it's on the opposite side of the sun somewhat, as we don't really see it on this side. So here's a 24-hour video It looks like there's actually a CME happening as we stream the video. So that's Jupiter showing up there on the coronagraph in the lower left. Zoom in a little bit closer at these CMEs. These do not appear to be earthly directed coronal mass ejections. And another indication that this filament is on the far side of the sun is that we don't really see it in 193 angstroms. So it's great at showing the extended corona. We don't see that down here. So that's an indication that that's on the far side, and that makes it an even bigger filament. That filament right there is certainly a huge helmet streamer, as they are called when they're around the heliographic polar regions. And by the way, that's a feature that we see more commonly around solar maximum, which we are still over a year away from. So here's just 193 angstroms by itself. A great wavelength to show coronal holes, filaments, active regions, as well as the extended corona. And let's take a look at filaments from the ground-based Hydrogen Alpha telescope at El Teide, Spain. So again, huge filaments here. The Shack filament looks like it's becoming unstable, and no surprises there as it's got a somewhat active sunspot just to its north. Also, you can see some prominences over here, and this one up here and this one over here could certainly get a name. And if you want to name filaments, join us over on Twitter. Follow the hashtag #NameThatFilament. You'll see the historic filament names. In fact, the last time we had a significant geomagnetic storm from a coronal mass ejection, it was named the Tamitha-Skov filament, interestingly enough. And let's take a look at the last 24 hours in STO 131 plus 304 angstroms. So that's another 24-hour video for you there, folks, as we make sure that we give you the holistic daily space weather. Here's the past couple of hours from the GOES 16 SUVI. Again, it looks like there is a CME actually happening as we speak. I suspect it's from this series of prominences up here in the northwest. Those are some serious prominences there. And so, yeah, I mean, you might see pretty low levels of solar activity, and that does not mean that we've reached solar maximum. I mean, it's just basic math, folks. It's just basic math. So that's part of the reason why one of our merch items is Do the Math, because it's a pretty simple thing. And let's get to our bonus feature segment. So surface charging hazards and internal charging hazards are currently present around the planet. We've got surface charging moving into the Central Pacific there, moving out of western Mexico, and internal charging here over the Indian Ocean at the moment. Don't be surprised to see that continue. That's the satellite's community dashboard, by the way, if you're interested in following that information yourself. The satellite's community dashboard, part of the Space Weather Prediction Center. So lots of different data sets for you to follow there if you like. And let's take a look at the GOES electron flux here, a little bit higher than we anticipated. That's the 3-day radiographic measurements by the GOES 16 and GOES 18 from their geosynchronous near equatorial orbits. And there is the forecast model. So we had kind of lower levels here than forecast, but not particularly low. And then now tomorrow, since we are expecting a CME impact, we're expecting to see this drop way down here. So when the CME impact occurs, expect a big dip in the electron flux. It's a regular feature of coronal mass ejection impacts and coronal hole high-speed streams. So let's take a look at the one-year graph. There's the one-year graph to put all of that in context. We're sort of at the high end here of the operating range. And let's take a look at the layer of the ionosphere where the electron flux is measured, the F layer, which is located at 300 kilometers of altitude. Here's the vibrational frequency in megahertz. Millions of vibrations per second. And thanks, Mrs. Lamovics, for rating with a party of one rater. I don't know what that means, but thank you. Thank you very much. Anyway, there's the vibrational frequency of the ionosphere, and we do see some certainly major low-frequency anomalies happening. Don't worry if you're not familiar with this data set. we've got the anomalygram for you as well. So here's the anomalygram. You're going to see a lot of red on that map, especially around the South Atlantic anomaly, which is located right about here where my arrow is, but also some other major low-frequency anomalies happening. So lots of red there on the map. That is the anomaly in megahertz from a 30-day median, blue for high-frequency anomaly, and red for low-frequency anomaly. And we'll show the latest image. There is 1145 universal time ionogram and 1145 universal time anomalygram. We'll also show the total electron content, which is certainly going to work out for the global view. I'm not sure about the North American view. It was not working when we did show prep. The total electron content depicts the free electrons from your GPS satellite down to your handset. And there can be signal refraction caused by those free electrons, which will be depicted here in the total electron content forecast. CTIPE stands for Coupled Thermosphere, Ionosphere, Plasmasphere Electrodynamics Model. That's your total electron content forecast showing you the most likely places to see GPS errors. If your GPS is expected to produce errors, try using Wi-Fi location accuracy if your navigation is taking place where there are Wi-Fi hotspots. So we can't show you the North American data here. It's just not working at the moment. So let's move on to latest intensitygram and latest colorized magnetogram. Again, this area here is not a sunspot. It's just a plage. No sunspots there. This did get a name, but it's looking weak since yesterday. And do we have any new sunspots rising in the north? Nope. We do have some fields rising. You can see a little bit of magnetic fields happening up there, but no new sunspots, and most importantly, beta gamma delta class. That is a beta gamma delta class sunspot. That is the most likely type of sunspot to produce major flares. And the reason that it's a beta gamma class sunspot that's in the process of change. So, for example, right here, let me bring out the pencil. Right here, you can see this red area. That's what we call a delta. That is the fields changing. We have this North Pole umbra right here, and then this strong South Pole magnetism right here. This strong North Pole magnetism right here behind this South Pole umbra. That's another delta. Back here, this red here, that's delta. That's a delta right there. All of those magnetic field complexities, those are what we call deltas, where it's basically an unsustainably complex magnetic field. And, that plasma reorientation is what we believe causes a solar flare. In other words, we don't say solar flares cause coronal mass ejections. In fact, we actually believe that the plasma motion is what causes the flare, as a lot of material has to take a completely different route. And that sudden change in direction is what causes the emission of those photons, we think. Anyway, you can see lots of deltas there on there. A great example of a beta gamma delta class sunspot. Now, if that was just two fields without all of that magnetic complexity close to the other organized fields, it would be a beta gamma class sunspot. But with all of that magnetic field complexity, that is a beta gamma delta class sunspot. Hopefully that helps. I know it can be a little bit tough to understand all of the different features of heliophysics. And let's move to meteorology. But first, take a moment to press like and subscribe. If you haven't done so, congratulations on realizing the channel exists. Press the share button, press comment, etc. Thanks to everybody who's tolerated the utterly putrid and pathetic censorship on all of the, quote, social media platforms. I mean, social media platforms are about as social as chaining yourself to the wall in the basement with nothing but cans of split pea soup and bottles of vodka. Thanks again to our YouTube subscribers for tolerating the platform itself. Also, make sure you follow us on Twitter. Will you be our 400th Twitter follower? And no, if you're wondering about free speech being fixed, free speech is not fixed. Elon did not fix free speech. The deboosting features continue, as Elon has publicly stated. Let's go wave chasing next to kick off our meteorology segment. And the world's largest waves right now really aren't that large. It's fairly calm seas around the planet. The largest waves on Earth right now are about 28.6 feet just west of the Drake Passage. You can actually see wind flowing from east to west around the Drake Passage. And of course, that's a real weird spot, as that's the location where the Atlantic and Pacific Oceans endeavor to reach static equilibrium. Anyway, that's what's going on with waves. Again, we'll show you the significant wave. By the way, the animation here is wind. The animation is wind, and the coloration is significant wave height. We're just showing you the whole planet here to show you that those are the planet's largest waves at the moment. It's pretty smooth sailing for most mariners. All right, anyway, let's switch to our regularly scheduled surface winds and jet streams. So there are the surface winds of the east. There are the jet streams of the east. Quite calm around the equatorial region right now. Here are the jet streams of the Americas. Doubled up jet stream and even a tripled up jet stream over the eastern portion of the U.S. Surface winds are shown here. By the way, we've got blizzard warnings in the U.S. Next, surface winds of the central world. It's a windy day in the central Mediterranean. And these are the jet streams. Shout out to Tadej Pogačar for winning the Tour of Flanders on Saturday. Not exactly an easy race to win, but indeed he was one of the race favorites. So that's a jet stream scenario for the central world, and let's move into clouds and fog. So here's some great satellite imagery from you. Please help me with my prepositions. Here is some clouds and fog imagery from the NASA GOES Interactive Weather Satellite Suite. It's pretty sweet to be able to see clouds and fog at nighttime. And if you're mad at NASA for lying about the shape of the planet, you should probably check out our merch shop to help you understand that Earth is actually shaped like a croissant. Yeah, the French or perhaps Swiss breakfast pastry. Croissant Earth, here it is projected onto a fake Adobe Photoshop spherical model so that Neil deGrasse Tyson and NASA can try to convince you that the planet is an oblate spheroid instead of a croissant-shaped, a croissant-shaped object. Anyway, here's your weather.gov map, and if your location's lit, head to weather.gov and click your location. There are too many counties lit there. By the way, all that orange in the north-central portion of the U.S. is blizzard warning. There are also tornado watches and flood watches around the Gulf Coast. So again, take your warnings seriously. There's some hard freeze warnings in southern Pennsylvania and parts of New Jersey also. Weather.gov is where to get your weather alerts, and check out the epic ice storm. There is an insane ice storm coming to the Great Lakes region, mainly in Canada, but also Minnesota and Wisconsin. It's going to then curl around and hit parts of New England. Look at the ice. That is an absolutely berserk ice storm. There is going to be ice accumulation from that. You may find yourself able to ice skate just in your backyard, just on the grass. Expect significant ice accumulation. And yeah, I mean you, Mike. That is a lot of pink. That is actual ice. You can expect ice accumulation here. Maybe a half an inch of ice, 3/4 of an inch of ice or something like that. That is a truly berserk forecast. That's the GFS 72-hour pressure and precipitation forecast. And look at all the pink and purple on that map. That is insane. Major ice storm coming. Be prepared for that. Next, total accumulated positive snow depth change in inches. That's also the 72-hour GFS model. And about 2 more feet of snow coming to portions of Wyoming. Also, don't forget those blizzard warnings that we talked about earlier. A blizzard is not a place to be getting lost in the snow. I guess if you have the right gear, you'll be fine. Anyway, again, that's your 72-hour GFS positive accumulated snow depth change in inches. And let's take a look at the difference between the Euro and the GFS model. So there's the Euro model. That's the GFS model, actually. Here's the Euro model. Pretty similar there. That's the next 3 days of new snow on the European model. And there's the next 3 days of new snow on the GFS. A little bit of a different storm track there. The Euro model tracking it farther to the north. I'm sorry, the Euro model tracking it more to the east. GFS model tracking it more to the north there. And let's continue on here. We don't want the video to be too lengthy. Here is your lightning mapper and severe lightning here. Moving from East Texas, going due east, and we've got 2 active cells, I think. Let's check our real-time lightning map to verify that from lightningmaps.org. So indeed, around Montgomery, Alabama, and that system likely moving almost due east there. So Montgomery, you're in the crosshairs here. You're going to have some extended periods of severe weather. That's a major thunderstorm there with that many lightning strikes, multiple very active cells. Well, that's what's currently going on. Again, heed your weather warnings. We've got some tornado watches and so on around the Gulf states. Last but not least, we'll show the U.S. Doppler radar map. There is the full 50-state view of former nation, now Banana Republic, known as the U.S. That's what's currently going on. Some missing data there on the Doppler. And we've got to refresh some things, so please bear with us. And my browser just completely crashed. So that's suboptimal. We'll bring it back up here. Just give me a moment. This video was originally streamed live, by the way. And you can find links below the video to where we usually stream live. There is a reason why we pick some platforms over others to do certain things, and it's because of their quality. It's because of the quality of the software, folks. I know, it sounds crazy, right? So let me just bring my browser back up here so I can show you the final images that we wanted to show. And by the way, let's go back to warp. Engage. There we go. There's our warp sound coming back. And just let me bring up the water vapor map and the shortwave radiation to close out the video. Ah, yes, the dangers of streaming live. It's so spooky. I'm scared and spooked here at the Smash News Network, least busted name in news. Again, we hope you're curling up in your bunker with a galactic current sheet so that you reduce the likelihood of your bunker mates deciding to eat you and using your status on whether or not you should be eaten. Whether or not you've been jabbed is the reason why some cannibals may not want to eat you. Anyway, here's our shortwave radiation map that shows clouds and fog. You can see this slightly southeasterly. It's east-southeasterly in its motions there. And here's the water vapor map. That should clear things up. We've got this another high-pressure impulse here from behind this weather. So that's effectively a high-pressure system, and it's also bouncing into this high-pressure system. So another great example here of atmospheric physics at play. Huge pressure gradient happening right here. And that is the source of those strong storms. Anyway, here's your recap. U.S. Doppler radar. The strongest portions of those storms are the southern portion. There's going to be some training happening there. Some areas are going to get hit with multiple severe thunderstorms there. So be prepared for that. Here is your shortwave radiation showing clouds and fog. And let's do one bonus feature here for once. I'll show a great close-up of that massive pressure gradient there. And by the way, this is the sort of thing that causes tornadoes. Now, if this air was coming farther south like this, that would be colder air, and that would produce stronger storms. That's what causes tornadoes. Tornadoes are caused by cold air crashing into warm, moist air, typically from the Gulf of Mexico. Anyway, that's where we'll close things out. Thanks for tuning into the Smash News Network, least busted name in news. We'll see you soon with some more content, and don't forget to visit the links over here and here and here.